Good morning. This is Unit 1, Test Corrections Help. Keep in mind that this video is designed to help you guide you to the answer and not give you the answer. So although this might give you a pretty good idea of how to solve these problems, you still have to show a little bit more work in order to receive points back on your exam. So let's start with number 1. Here is a polygon. Draw a scaled copy of a polygon using a scale factor of 1/2. So what is a scaled copy? A scaled copy are just copies of a figure in which all lengths have been increased or decreased by the same scale factor. So if I am to draw a scaled copy of this specific polygon, I am going to go ahead and measure the length of this polygon all the way around. So you can notice here that this would be a length of 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And I would go ahead and mark all the way across. Around. And then, knowing those lengths, I could go ahead and apply my scale factor. Now, if I'm making a scaled copy with a scale factor of 1/2, that means I'm going to be 1/2 the size. So that means that when I draw my scaled copy, its corresponding side that I just highlighted will no longer be 8, it would now be 4, because 8 times 1/2 would be 4. And I would do this around every single side of my polygon, so that way when I draw my scaled copy, I know all the lengths of my scaled copy to be able to draw it. All right, let's go ahead and move on to question 2. A scale drawing of a rectangular park is 5 inches by 7 inches long. The actual park is 280 yards long. What is the area of the actual park? Now, a quick reminder, whenever you're finding area of a rectangle, the formula in order to find it would be length times width. Now, it might seem easy to find the area of this scale drawing, but keep in mind that they're asking us what is the area of the actual park. So, if you find the area of this scale drawing, you say, hey, the area is 5 times 7, which would then give me 35. Unfortunately, that would be incorrect, because it's your job to find the area of the actual park. So let's go ahead and see how we would do this. I know that this is my scale drawing. I know that there exists some real world park out there. Now, if I know my scale drawing is 5 inches wide and 7 inches long, and I know that the real world is 280 yards long, well, I know that somewhere out there in the world, there is some park that's 280 yards long. Now, how in the world am I going to find the area of my actual if I have to know the length times the width? Well, I know what the length is, but what would the width be? Now, this is where we could draw a table to help us out. Now, if I draw a table with my scaled values to the left and its corresponding measurements to the right of my real world, I could go ahead and see if I have any corresponding parts that correlate. For instance, notice that these are two corresponding parts. That means that 7 inches corresponds to 280. Now, I could use what I know about tables to figure out, okay, what would be my scale factor? What would be that number that I have to multiply 7, so that way it equals 180? And the answer to that would be 40. So I could go ahead and be like, all right, now that I know my scale factor is 40, I could find this corresponding side by knowing its corresponding side, putting my scale factor, applying my scale factor, going over, and figuring out what the width would be, so that way I could find the area and multiply the length times the width. All right, number 3, rectangle A has a measurement of 9 inches by 3 inches. So let me go ahead and draw a really quick sketch of that rectangle. Now, of course, it ain't going to be perfect, but good enough for our use. Now, rectangle B is a scaled copy of A. Select all the measurements that could be dimensions of rectangle B. So let's say that this is rectangle B. It's not drawn to scale. Let's go ahead and draw a really quick sketch just for visual purposes. Now, I can see that I'm going to go ahead and test to see if this is an option. If option A, can a rectangle of 4 by 5 or 4.5 by 1.5 be a scaled copy. Now remember, a scaled copy are copies in which all lengths have been increased or decreased by the same scale factor. That means it's your job to check if there exists a scale factor that multiplies all the corresponding sides to equal, that multiplies all the sides of our original to equal the corresponding sides of our scaled copy. So let's think about this. 9 times what equals 4.5? Well, I can see that 4.5 is half of 9. So that means I'm going to double check to make sure that all my sides of my original copy have been multiplied by a scale factor of 1/2 to equal the corresponding sides of my scaled copy. Now, what is 3 times 1/2? Well, if I think of 3 times 1/2 would be just 1.5. So that means that this could be an option. It can't happen. Now, as we move on and go through all the options, you pretty much just have to do the exact same thing for all of them. You're testing to see if there exists a scale factor in which shows you that these are scaled copies. Alright, so problem 4. The scale of a map. The scale of a map reads 4 centimeters per 5 kilometers. Represents 5 kilometers. Fill in the values in the table. So, as I see this table, I notice that my centimeters are to my left, my kilometers are to the right. Now, we practice a lot of putting our scaled values to the left and putting our real world values to the right. So, with that being said, how in the world can I find these missing values? So if you remember, there is a scale factor that multiplies all the values in your scale to equal the corresponding lengths in your real world. And it's your job to figure out what that is. Now, if I look at this 4, what could be the scale factor that I have to multiply to equal 5? 4 times what value equals 5? Now, of course, I can't think on top of my head what multiplies 4 to equal 5, but I could use reverse division, in which I take my solution, divide it by my multiplier, and it will tell me what that solution is. Now that I figure out what that solution is, I can use that scale factor to be able to translate all my scaled values to find out my real world values by multiplying by that specific scale factor. I don't know what that specific scale factor is, but you can use it in order to find and figure out the table. Now, what happens in this instance here when I have a 4, that is my real world, and I have to work backwards? Well, remind yourself, what's the opposite of multiplication? It'd be division, so you can divide those values to work backwards. So make sure that you use the arrows, put as much visual, so that way it can help you figure out how to solve this problem. All right. Question 8. Quadrilateral EFGH is a scaled copy of quadrilateral ABCD. Select all the true statements. So looking at these two quadrilaterals, I know that they're scaled copies. Now that means that there exists a scale factor that multiplies all the values of my original figure to equal the scaled values in my scaled copy. There's corresponding sides, that is. So let's go ahead and see 2 corresponding sides to see if we can figure out what that scaled copy is. And notice I highlighted those two upper lengths. Those are the corresponding parts. Now, looking at the 6 and the 12, what would be my scale factor? 6 times what is 12? Well, I can see here that it would be 2. So that means I could go ahead and find all the missing values by applying my scale factor to all the sides of my original to find the corresponding sides in my real world. For instance, if I look at this 4 here, 4 times 2 is 8. 3 times 2 is 6, and of course 8 times 2 is 16. Now you could go ahead and read all those statements and make sure that you find which ones are correct and wrong. For instance, segment EF is twice as long as segment AB. Well, what is the length of EF? EF here is 6. What's the length of AB? Well, AB is right over here. Notice that AB is 3, so is EF twice as long as segment AB? The answer would be yes, because 6 is twice as large as AB. Now, since this was extra credit, I'm not going to go over it in this video. Maybe in class when everyone has taken their test.